Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's challenging level puzzle. And it's called Sum Product Yin Yang by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have yin yang, where we need to shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected. And no 2x2 area is fully shaded or fully unshaded. So this is an example of a valid yin-yang shading, because to get from any cell in the shaded region to any other cell in the shaded region, what does orthogonally connected means? It means that you can get from one cell in the shaded region to any other cell in the shaded region just by going through edges, all while staying within the region. So for example, to get from this cell to this cell, you can just go through these edges here, and you'll always be in the blue region, and you don't have to go through a corner. This is not a valid example of a shading if we add this to as a shaded cell, because to get from this cell to any other cell in the shaded region, you have to go through a corner or you have to go to the other region to do so, and that's not allowed. Same with the unshaded cells here too, right? The unshaded cells are not, these cannot get from this part to any of these cells because you would have to go through either a corner or go through the shaded region to get to the other cells through an edge. This is also not a valid shading because you have a 2x2 area that's all shaded then in that case, which is not allowed. And those are examples of how yin-yang work. And we have some product cages, where the number in the upper left corner of a dotted cage gives a sum of all shaded cells in the cage, and it also gives a product of all unshaded cells in the cage. And digits may repeat in cages if allowed by other rules. So, for example, well, this is probably not a good example. Let's use this. In this cage, the shaded cells must sum to 20, which is in the upper left corner of the cage, and the unshaded cells must multiply to 20. So that will give you certain, well, that should give you some certain knowledge about that. I won't give an example because that sort of starts solving things. For example, in the 16 cage, these two cells here must add up to 16, and these three must multiply to 16. That should also give you some examples if you think about it closely. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. What we have here is interesting. So, the digits here must add up to 25. That's at least 4 digits. But to multiply to 25, you have to have a 5 and a 5. And it has to be different ones. So it has to be 5 here and then 5 in one of these two cells. But in yin-yang shading, once you swap twice on the edge of the grid, you can't swap anymore. And so let's see this in, let's try it out, right? Say it was like this. This was, so we know 5 has to be here, and it has to be multiplied with 5. So that means 5 has to be here, and then one of these is 5, cannot be here because of 5 in the same box. So it has to be one of these two. What happens if it's here and then this swaps back? Well, the problem is, try to orthogonally connect the green cells without essentially connecting or whatever. we can just do something like this. This is green here, and then this is blue. Try to orthogonally connect the green region without breaking the blue region in two. And the answer is you cannot do that, right? So you try to orthogonally connect the green region in some way. That means this blue region's definitely blocked from the connecting to the rest of the blue region. Try connecting this way. Obviously, it's the same thing. Connecting this way, it just doesn't work. And then try connecting the blue region together orthogonally. Then you'll break the green region into two regions at least, which is not allowed. And I usually use blue region for shaded and green region for unshaded. So you can only swap twice essentially on the edge of grids if you have a swap at all. And we have to have a swap here. So therefore this must be green, and this must be blue, and then this must be green. So that means you can't swap again because of the same logic there, right? So say you swap somewhere here then, right? You still have the same problem, right? Connect the green regions orthogonally together, and you'll break the blue regions into two regions, which is not allowed. Connect the blue regions together, you'll break the green regions into two orthogonally connected regions. So since this switches here and this switches here, that means the rest of the edge must be green and unshaded. This is a 2x2 area that has three unshaded, so this must be shaded, this must be shaded, this must be shaded. This is a 5, and this is a 5. So they multiply to 25. So 15 is interesting also. It must be 3 times 5 as multiplication, and the addition must be then 2 digits, 6 and 9, or 7 and 8. We're not sure which. So we're guaranteed a 3 and a 5 here to be multiplied, and then we have 6 through 9, and 6 or 9 or 7 and 8 to sum up. And the sum is the shade, so this must be 6, 7, 8, and 9 here. 20. So this is 5, 5. We have a 5 guaranteed to be here. Well, 5 cannot multiply to 16. You need at least 2 shaded cells to multiply to 16, and it has to be 2 and 8. You could have 2, 8, and 1. You have a 5 guaranteed here, so to sum to 16, you can't have 2 digits. It has to be 3 digits. So we need to have 2. 5 can't be here because of the 3-5 pair in the column to multiply to 15. So 5 has to be one of these two. And then we have 2 and 8 to multiply to 16 as 2 digits, because it has to be 2 digits, because with 5 and you can't have 2 digits adding to 16. So it has to be 3 digits adding to 16. So it's 5 with 2 other digits adding up to 11. Well, you have 5. You have 2 and 8 as the multiplication in the box. And it has to be 2 times 8 because you can't have 4 times 4 because it's all in the same box. To add up to 16 with 5, it has to be 11 for the other 2 digits. Well, 2 9s were removed because of the 2 in the multiplication part. 3 8s were removed because of the 8 in the multiplication part. So this has to be, what, 2 or 8? No, 8. The shaded is the sum. So 5 has to be here as the shaded, which means this can't be shaded here, which means this is shaded. So then this is a 2 8 pair here. So this is 5, and it has to be with, cannot be 2 9, cannot be 3 8, cannot be 5 6 adding up to 11. It's 4 7. So this is guaranteed to be 4 and 7 here that add up to 11. 11 plus 5 is 16. So the 4 7 pair eliminates 4 and 7 in the rest of the column. So this cannot be 7 and 8 adding up to 15. It must be 6 9. So we have a 3, 5, 6, 9 quadruplet in column 8, too, along with a 4, 7 pair. That means the remaining digits in the column cannot be 3, 5, 6, 9 or 4, 7. We have 2, 8, 1 as the remaining digits in column 8. And this can't be 2, 8 because of the 2, 8 pair in the box. So this must be 1, and this must be a 2, 8 pair here. Interesting. So these digits add up to 25. You can't have a 1, you can't have a 5, so that eliminates 1, 7, 8, 9. You could have 2, 6, 8, 9. You cannot have you could have 3 with 6, 7, 9. Except that okay, so the problem is, so the remaining digits in this box are, what, 3, 6, and 9 in box 3. So to add up to 25, you cannot have, so you could, again, you cannot have 1, 7, 8, 9 because of the 1 in the row. You could have 2, 6, 8, no, you can't have 2, 6, 8, 9 because that would force both of these to be 3, and we'd have duplicates in the same row. So it cannot be 2, 6, 8, 9, which means the 2 cannot be the part that's summing to 25, which means this is guaranteed to be a 2. So then the remaining digits must have a 4 and a 7. So 25 plus 4 and 7. Sorry, 25 minus 4 and 7, which is 11, is 14. That means it's either 5, 9, or 6, 8. It cannot be 5, 9 because of 5 in the row. So this must be 4, 7, 4, 7, 6, 8, which eliminates 4, 7, 6, 8 in the rest of the row. This can't be 6 here. This can't be 6 here. It's a 3, 9 pair, which eliminates 3 and 9 in the rest of the box. So this is 6. Also, this is a 2 by 2 area, which is all shaded, so this must be unshaded. This is a 2 by 2 area that's all unshaded, so it must be shaded here, so it's blue. Another thing, another axiom, or is it lemma? I don't remember. Another thing you know about yin-yang shading is if you have a diagonal going one way here, that's the same shading. You cannot have a diagonal being of the other shading going the other way. And the reason is, try to orthogonally connect the blue regions from this diagonal. Well, you'll break the green into 2 regions. And if you try to do it the other way, try to connect the green regions to orthogonally, you'll break the blue regions into 2 regions then, if that's the case. So we know that this, because this diagonal is both shaded, this must be shaded too. So that's good there. 35 requires a 5 and a 7 to multiply. To add to 35, you could have repeats. Well, okay, you have to have a 5 that multiplies. So 5 cannot be here, and 5 cannot be here, so 5 has to be here. And again, it's part of the unshaded region. So this is unshaded. We need a 7. You can only have 1 duplicate. You probably have to have that duplicate. Yes. If these were the multiplications, so this cannot be 5 here. If these were the multiplications, say we had 2 multiplications, then the problem is these digits can never add up to 35 because it's maximum of 4, 6, 7, 8, 9, which adds up to 34. So this cannot be green. It has to be blue, which means 4 of these are the same. 1 of these is the same. Because, oh, you could have 4 digits, actually, though. Yeah, 7, 8, 9. No, you can't. You can't have 4 digits in this cage adding up to 35. You have that would be at maximum 789 plus 9, which is 24 plus 9, which is 33, which is too small. So you have to have 4 digits here adding up to a certain amount, plus another digit here. And this you have to have one multiplication. So one of these is guaranteed to be a 7. So that means the minimum of the other 3 is 6, 8, and 9. Or no, sorry, 4, 6, 8, and 9. That's 27, I believe. Yeah. 4 and 6 add up to 10, 8 and 9 add up to 17, that's 27. So then this is at least 8 here. So this is 8 and 9. This is guaranteed to have a 7 to multiply to 35. And you have to have 8, 9, and 6 here, and then either 3 or 4. Because only the 4 could go down 1, right? You can't have a 5 here because of 5 in the column. So you're guaranteed 3, 4. You're guaranteed 6, 8, 9, and 7 here. 7 to multiply with 5 to multiply to 35. And then you have 6, 8, 9 at least here, because this is 8, 9 at most here. So if you tried to have 3, 4, 8, and 9, that's too small, right? 7 plus 8 plus 9 adds up to only 24, plus 9 at most is 33, which is too small. So this has to be 1, 2 with 3 or 4 here. We're not sure which. And we're guaranteed 1 and 2 are here. This is 5. This 20 needs to be multiplied, must have a 5 that multiplies there. And 5 cannot be here, 5 cannot be here, so 5 has to be one of these 3 to multiply to 20. So 5 can't be here, 5 can't be here. 5 is one of these 4 here. 5 has to be one of these 3 here. Okay. One of these, I think, has to be a 1. To multiply to 20, you cannot have a 5 here. And again, the unshaded cells are the product. So if you have any other combination besides 1, 4 or 1, 2, it doesn't work, right? Because 20 factorized is 5 times 2 times 2. So that can have, you have to have a 1 here, and it's with 2 or 4 here. So you're guaranteed a 1 in one of these cells, and with 2 or 4 there. 5 and 4 could just multiply to 20. So what happens if we have just a 5 left here? That means the remaining digits will guaranteed a 5 here. So one of these is blue. One of them has to be blue to connect out. Actually, it has to be 3 blues. Well, I mean, obviously. Can you have one? So one of these is guaranteed to be green. You could have all of these be blue. That is possible. Okay, so maybe that's not helpful there. 5. So this is, it could be 3. Okay. 2 and 8 remaining here. This multiplied to get to 21 has to have a 3 and a 7. But that's all it really requires. Hmm. 32. Oh. We only have one digit that's outside. the box, which means there's only one repeated digit. So get to 32. You have it's basically 2 to the 5th power. So we have access to 8, 2, and 4. This can't be 3 to multiply. Um, you could have 4 times 8 times 1. You could have 2 times 8 times 2. What else could you have? So where's 2 in box 5? It has to be one of these 3. So 2 times... Okay, this digit can be one... Any digit that's multiplied can be 1, 2, 4, or 8. That's it. Obviously, this can't be 1 or 2 because of the... you could have 2 times 4 times 4. So to multiply to 16... Or sorry, to 32. Oh. You could have 4 times 8. Hmm. Okay. In column, in this 35 cage, both of these cannot be blue, because then we'd have a 2x2 area that's all blue. So one of these is green, which means one of those is a 7, which means none of these can be 7. So these are all blue here. So we've got all blue here. This is guaranteed to have a green, and it has a 7. So this can't be 7 here. That means we're guaranteed in box 1 a 7 here, and we need a multiply by 7 in this 21 cage. So none of these can be 7, so one of these 4 is a 7 here to multiply to 21, but we don't know which. Okay. So these are all blue. Here, one of these diagonals must be green, the other must be blue, but we don't know which is which. Hmm. Hmm. 4 times 8 kind of works if it's 5 digits adding up to 32. Can you have... you can't have this be green. If this were green, the problem is these would have to add up to 32 with 4 unique digits, and that would be 6, 7, 8, 9 at minimum. So this cannot be green, this has to be blue. Since this is blue, we have a 2x2 area that's all blue, so this must be green here. Therefore, this must be 1, 4, and 8 multiplied together to give you 32 at most, right? Can you have... Yeah, you could have that digit be blue if all of this is blue. So it's only 1, 4, and 8 in the green region here. So this 2x2 area is done. So we have 7 guaranteed here. 7 in one of those 4 cells. Okay, can you have 4 digits add up to 32 with one of them being duplicated? 7, 8, 9 plus 8 works. 6, 8, 9 plus 9 works. Yeah, so possibly. as long as this is the green digit. If this were blue here, and we had 3 other blues, so say these were guaranteed, say we had this with 2 other digits in this box to add up to 32. This would be at maximum 4 plus 8 plus 9, which is 21, plus 9, which is 30. So this cannot be the only blue here. So if this is blue, that means all of these are blue. If this is green, that works as long as the rest are blue. So if this is blue, the rest must be blue. If this is green, the rest must be blue. So the rest must be blue, period, then. So these are our blue, and we don't know what this is. Right, we tried to have it where this was blue without all of these being blue, and that's not possible. Because, again, this adds up to 21 plus 9 at most, which adds up to this very small number. Can this ever be 2, actually? If this were a 2, this would have to add up to 6, 7, 8, 9, but we know that 8 must multiply to 32 here. So no, this can't be 2. What is the maximum this, or what's the minimum this digit can be then? We are guaranteed at most 5, 6, 7, 9 to add up to whatever. So 5, 6, 7, 9. 5, 6, 7 adds up to 18 plus 9 is 27. So this is at least 5. And it cannot be 5 because of 5 in the box. So this is 6, 7, 8, and 9 here. Oh, wait, but we could have this added on. Yeah, this could be a 2 here. This could even be a 1 here. 1 plus 7, 8, 9. There's no 8. 1 plus 6, 7, 9. 1 plus 6, 7, 9. 6, 7, 9 is 22. Plus 1 plus 9 works. So this could be 4 here. So 4, 6, 7, 9. 6, 7, 9, 22 plus 4. Oh, it can't be 4. There's no 4 in... Yeah. It would have to be 3, 6, 7, 9 at most. If this were blue. Because the 4 has to be multiplied... It has to be part of the green region here. So this can't be 4 either. But this could be 1, 4 as a pair, and then 8. Oh, we need 8 somewhere in this region. So this it cannot... It has to be green here. Can't be here. Can't be in any of these. So this must be an 8. Which means this can't be 8 here. It's 2. Which means this can't be 2 here. It's 8. Which eliminates 8 here. This 8 also eliminates 8 here. So this is 9. Which means this can't be 9 here. Which means 35 minus 9 is 26. So 4 digits adding up to 26 must be 3, 6, 8, 9 without a 5. So this cannot be 4. This must be 3, 6, 8, 9, which eliminates 3 in the rest of the box. Or the rest of the column, sorry. So this cannot be... This has to be a 1, 2, 4 triplet. 9 eliminates 9 here. Okay. Can this actually be 2? It could be, right? 8 with 6, 7, 9. Remaining digits in box 8 are 3, 5, 6, 7, 9. The 9 has to be in the shaded regions, right? So this can never be 4 if it's shaded, because we need 4 times 8 to multiply to 32. So if this is shaded, it could be 2 with 6, 7, 9. If none of these are shaded... Now 5 can't be here. Um... Hmm. Hmm. 2 is here. Where's 2 in this 9 eliminates 9 here. So this has to be 3, which means this can't be 3, that's 9. 2 in column 7 has to be one of these two, because it can't be here because of 2 in the box, can't be here because of the 2-way pair in the box. 2 has to be one of these two, 2 has to be one of those two, so 2 in row 6 has to be here. Because of... Can't be here because of 2 in the box has to be there. Can't be here because 2 in the box has to be there. Interesting. Adding up to 32. You can obviously have 2 here with 6, 7, 9 here, and this being 8. Can you ever not have a 9 here? I think the answer to that is no. Right? 5, 6, 7, 8 would be 26 at least. Yeah, 5, 6, 7, and 8 here would be 26 plus... No, would be 26, period. 5 and 8 add up to 13, 6 and 7 add up to 13. So you're guaranteed 9 here, so therefore 9 in the box cannot be in the rest of the box. It must be in the shaded regions. What about 7? Can you have 7 here? Well, what's the maximum for 3 digits? For 4 digits, it's guaranteed to be 2, 6, 7, 9 with 8. Oh, it's 6, 7, 9 here for 3 digits. But then this can't be 9. So 6, 7, 9 is 22, which would require a single digit here, which means this has to be shaded to give you 5 digits to add up to 32, which would be valid. So then this must be 2 with, does it have to be 6, 7, 9? It can't be 3. This is at most 8. And this is at most 24. So yes, this is green. A green guest has to go out to orthogonally connect. So these are both green. 2 eliminates 2 here, so this is 1, which forces this to be 4. That means this cannot be a 1 here. So we know this has to be a 1 here to multiply to 20. Can you have 5 here? The answer is no, because this is 8 at maximum now. So 2 and 8 add up to 10, and this is 22 at maximum here. So this is not 5, this is 6, 7, 9. Therefore, that makes this a 5 here. Because of the 6, 7, 9 triplet, this must be 8. That eliminates 8 in the rest of the box. So now we have a 3, 6, 9 triplet in column 5, which eliminates 3, 6, 9 in the rest of the column. So this is a 7, 8 pair. That eliminates 8 in the rest of the box, so this can't be 8. Therefore, we know 8 also has to appear in row 1 in this box here. This can't be 6 or 7 because of a 6, 7, 9 triplet in the box. So this is 3, which means this can't be 3. So where's 3 in this column here? It must be one of these digits here. Also, we have a 3, 6 pair in row 6, which eliminates 3 and 6 in the rest of the row. So that leaves the remaining digits as 2, 4, and 7. So this is 4, 7, this is 2, 4, 7 in the row. We're guaranteed 3 here. 3 can't be here in column 9. It can't be here because of the 3 remaining in this cage here. So 3 has to be one of these 2 cells here. 2 has to be here. 2 has to be here. We have to have a 2 here. Interesting. One is here, so 1 cannot be here or here. We have a 6, 7, 9 triplet in row 8, which eliminates 6, 7, 9 in the rest of the row. That means 7 has to be one of these two digits, which means this cannot be 7 here. Remaining digits in row 8 are 1, 3, 4, 5, 8. 1, 3, 4, 5, 8. No 7. 1, 3, 4, 5, 8. 1, 3, 4, 5, 8. This can't be 1 or 5. This can't be 5 because this must multiply to 20 with the 5 here. No 8 here. No 3 or 5 here. Okay. Hmm. 21. We need 3 and 7. Okay, what are the sums that add up to 20? We're guaranteed a 2 here and a 2 here. But you can multiply 2 and 2 to give you 20. Okay, so we are guaranteed here, if it's 4, none of these, the only only green cell which to multiply to 20 would have to be the 5. So the other 2 cells would be blue. If you have 2 here, you have to have a 2 multiply here, but then again, you have a 5 and 2 blues. And the 5 again is the green. Okay. What about remaining digits in box 5? We have 1, 2, 4, and 7. Okay, so this is 1, 4, 7 here. And this is 1, 2, 4, 7 here. Okay. Remaining digits in box 2 are 1, 3, 4, 6, 9. No 6 here because of 6 in the row. Remaining digits in box 1 are 1, 2, 3, 4, 6, and 9. No 1 here, no 6 here. Okay. So this is the sum of at least 4 digits, but it could be 5. Doesn't really help us much. If you had this as a 4, that means 2 would have to be here, 2 would have to be here. And therefore that would guarantee 2 here. Which would make this 8, make this 7. Again, the 5 and the 7 would multiply to 35, so this would be green, which would force that to be blue, but that doesn't tell us much. And then this would be blue, so then this would be blue here. So if you have 4 here, it must be with 5 to multiply to 20. The rest add up, so it's 2 and 2. That's 4. Not really restrictive. Okay, remaining digits in column 7. We have 1, 2, 4, 7, 8. Yes, 1, 2, 4, 7. And this can't be 8 because of 8 in the box. 1, 2, 4, 7, 8. 1, 2, 4, 7, 8. No 2 here. No 4, 8 here. No 1 here because of digits in the row. So guaranteed an 8 in one of these cells there. Okay. Um, okay, 1 cannot appear here in this cage, but 1 could appear in any of these cells. That ain't helpful. Hmm. Oh. Remaining digits of column 9. No 3s, because the 3s have to be here. Okay. Maybe the remaining digits of row 9. We have 1, 3, 6, 7, 9. This can't be 9 because of 9 in the column. No 1 because of 1 in the column. That's not helpful. Remaining digits of column 9. Again, the 3s are here. So it's 1, 4, 5, 6, 7. No 1 here because of 1 in the row. Okay. Hmm. If this is green, this becomes blue, blue. That seems fine. You have the 5 there. This can't be both blue, so it would be 2 times 2, which is fine. Where is 8 in row 5? It has to be one of these 3 cells because it can't be here because of 8's in the boxes. Okay. Let's just check these again. 5 times 5 is 25. 4, 6 adds up to 10, plus 7, 8 add up to 25. 2 times 8 is 16. 5 plus 4 plus 7 is 16. 3 times 5 is 15. 6 and 9 added together is... So 9 has to be one of these two. 9 is guaranteed to be one of these 3 then, because there's no other place for it in row 9. Hmm. Remaining digits of row 7. We have 2, 4, 5, 6, 7, 8, 9. That's a lot. No 9 here, though. Because the 9 in box 7 has to be one of these 3 digits. Okay. Yeah, this is kind of... Anyways, okay, so say this was a 4. That means these would be blue. So one of these would have to be green. Oh, that's interesting. Yeah. One of these is definitely have to be green here. So this cannot be the green and cannot be 5 here. So this must be blue. And if we try to have 5 blues. The problem is the green would have to be, if we had both blues here, that would force us to be green, but then the problem is, so if this was 4, this would both be blue, and this would be 1 times 4 times 5 multiplying to 20. I guess you could have a 1. Ooh, okay, you could have a 1 there. Ooh, okay. That doesn't give us. We do know one of these two must be green, though. I guess they both could be green. Huh. Why can't this be green here then? You can't have green here and green here. So say this was green here. If this was green, this is guaranteed to be blue here. This would have to be blue to go out that way. And then this would have to be green because of the 2x2 box. But then this would multiply already to 2 times 4 times 5, which is 40, which is too large. So that's why that cannot be green. And this must be, what? This cannot be green. This is blue, guaranteed. So 5 has to be one of these two, which eliminates 5 in the rest of the column. So in box 4, 5 has to be one of these two cells. Huh. So it must be adding to there. It's multiplying here. It could be 5 and 1. That is possible. If this is blue, blue, that forces this to be green, green. If one of these is green... Oh. So say this was green with that being green. So if these are both blue, blue, this is green, green, guaranteed. Because this would be blue, blue, this would have to be green. The green has to orthogonally connect to the rest of the green, so it must come out there. If this is not blue, blue, say it's green here, one of these two must be green. One of these two must be green. So if you have blue, blue here, that's green, green there. If we try to have... So if this is blue, this is green, green. If this is not blue, say it's green, that would mean blue is here. This would be green. At least one of these would be green. I guess you could have blue going here, green going here. That is possible. You could have green, green going here, though, also, and then this being blue. Okay, not that many possibilities there. Well, okay, say this was... If this is blue, blue, this is green, green. So this would be 5 and 1 multiplied with 4. 5, 1, 2. No, this is blue, blue. So 5, 1, 4. And this would be at least, at most, 2 and 7. This would have to be 2 here. Oh, that doesn't work. So if we tried to have 2 blues here, this is green, green, that's 5 and 1. This would have to, since these are not multiplication, these are blue, that add up, this must be 4. So 1 times 4 times 5 times 1 is 20. This would guarantee to be a 2, because there's no other place for it in the row. This would be guaranteed to be 2. And you'd have 2 plus 2 and 7 at most, and 2 and 8. That's 19 at most for the sum, which is not possible. So this cannot be blue, blue. One of these is green, the other one's blue, which means the green is 2, so this is 2 here. So this is 2 times 2. 2 cannot be here, and 2 cannot be here. So one of these is green, we're not sure which. It's a green-blue pair there. This still could be 5 times 1. Or just 5 here. We're not completely certain. That means this must add up to 20 with 4 digits. Can it ever add up to 20 with 3 digits? 7, 8, and you can't have 5 available. Seven, 7, and 6 could work, but then the problem is the 7 would have to be here. And this would be 7 and... You can't have a 7 or 6 here. It has to be with 8. Okay. So if we try to have this as green, green, we have 3 blues adding up to 20. With no 9 here and no 9 here, no 8 here. So 4, 7, and 8 only adds up to 19. So 7 would have to be here as the sum. 7 and 8 don't work because you need it with 5. 7 and 7 could work if you have a 6, but this can't be 6 or 7 because of the 6, 7, 9 triplet in the row. So you cannot have 3 digits here adding up to 20, right? 4 only does not work with 7 and 8. That's 19 at most. 7, if you have an 8, it's 5 and 8. But you can't have the 5 because the 5 must multiply to get to the 20 in that box. And if you try to have 4, 7, 6, this can't be 6 or 7, so that doesn't work. And then 7 with 6 as most doesn't work, right? 7, 6, 5 adds up to 18. So you can't have 3. It has to be just 4. So one of these is blue and one of these is green also. But we don't know which one's which either there. So you still could have 4 here, unfortunately. Oh boy. Okay, one of these is blue, one of these is green, one of these is blue, one of these is green. What you cannot have, though, is... So either... So whichever one is here, say if this was blue, that would force this to be green, and then this would have to be blue, and that would be green. That could work. Oh, wait, no, we have a 2x2 area that's all blue, so no, that doesn't work. So this cannot be blue, right? Again, if this is blue, this forces this to be green because we need to multiply. You can't have 2 blues here because that would multiply 5, 1, and then that doesn't add up because you have 2, 2, 7 at most with 8. So that doesn't work. So if you have blue here, this is blue as a diagonal, so this can't be green as a diagonal, so this must be blue. And we have a 2x2 area that's all blue, which is not allowed. So this can't be blue, this must be green here, which makes this blue. If we have green here, oh, that does work. Dang it. Okay, so we just know that that's blue, and that must be a 2. So there's no 2 here. That means 2 cannot be here. 2 can't be here. So 2 is one of these 2 digits here. This is still a blue-green pair. We have green here across here, so this can't be diagonal of blue. So this must be green here. You have 3 digits here and then a 4th digit adding up to 20. So can you have 1 there? I think so, right? Yeah. 1, 4, 8 plus 7. That works. Um, hmm. This is actually kind of tough for the like trying to figure out where these can be. Um, obviously you only need two greens in this 21 region. Um, uh, okay. Mm. Oh, this can't. Okay, so one of these must be blue, and one of these must be blue, because otherwise you have a 2 by 2 box in one of those areas be blue. If you had only one blue here, both of these would have to be green. So this can never be blue. This is green, which makes this 3 or 5 here. Therefore, we have a 2 by 2 area that has green, so this must be blue here, which means we have we have 2 blues already, so this must be 6 and 9 to add up to 15. This has to be green to multiply to 15, and this has to be 3, and this must be the 5. So that means this can't be 3 here. This can't be 3 because this is going to be 3 here, because this is 6. This 5 eliminates 5 here. That's good. Okay, so then this has to be the green and the 5 here. To multiply to 20 with the 2, 2, and 1. This is blue. This 9 eliminates 9 in the rest of the row, so this becomes a 6, 7 pair, which eliminates 6, 7 in the rest of the box. So this can't be 6, this is 9. That eliminates 9 in the rest of the column. This can't be 5. This can't be 5. Hmm. Okay. So this is green. We have blue, blue here. This is a 2 by 2 area that has all green, so this is blue. This is a 2 by 2 area that has 3 blue, so this is green. This is diagonal with green, so this must be green here because it can't be blue. This is a diagonal of green, so that makes that green there. This is a 2 by 2 area with 3 greens, so this is blue. 2 by 2 area of 3 blue, so this is green. And therefore, this is the multiplication part. So this is 7, this is 8, that's blue. This is blue, so this diagonal is blue, so this cannot be a diagonal of green here. So this must be blue here. Green has to get out to be orthogonally connected, so this is green. This is multiplication, so this cannot be 4, 6, it has to be 1 or 3 here. 7 eliminates 7 here, so this is 4, which means this can't be 4, that's 7. This 8 eliminates 8 here, so it's 2, which means this can't be 2, that's 8. That means 2 cannot be here. Where's 2 in row 3? It has to be here. So this is 2. These can no longer be 4. There's a 4 in the row. Okay, 2 is here. It cannot be multiplied, so this is blue. Because multiplication must multiply to 21, so it's 1, 3, or 7. Okay. What else do we have? I think it's not quite all the twos. Uh, okay, so blues orthogonally connected, greens. The blues have to orthogonally connect here, so then this is blue and this is blue. Okay. This is 2x2 area, that's 3 blues, so this is green. We have a diagonal of green there, so this must be green there. So this is green. It cannot be 6 or 9. It's 1 or 3. So this is a 1-3 pair, which eliminates 1 and 3 in the rest of the row. So this can't be 3, this can't be 1 or 3. We have 6 or 9 there. It could orthogonally connect here. Six eliminates 6 here in the box. Okay, we have 3 digits at most here, adding up to 19. Can you have 2 digits? No. So it must be 3 digits at least adding up to 19. Which means one of these digits is 7 and the 3 remaining digits are blue. Can you have a 2 here? 2, 2 plus 8 and 9, except that, well, I guess 9 could be here. So that is possible. So you could have blue being there. If you have green here, this would be 3 blues. That works. Okay, green can never be here. So if green were here, the problem is you'd have blue, blue, blue here. And then this would not be orthogonally connected to the rest of the green. So this cannot be green. This is a blue. So this can't be 7. Green connects to one of these 3. We're not sure which. And the rest are blue. Say you have green here. This is blue, blue. You have to connect this way for this green. Say this is green here. You still need to connect this part, so it has to connect there. So this will always be green here to connect. We don't know what this is. This is interesting. Again, one of these is green. Blue, blue. Green, blue. Okay, remaining digits. Remaining digits of row 4. Actually, let's do column 1. 3, 4, 5. No, 3, 4, 6, 7, 8, 9. No 3 here, no 8 here. Okay. Remaining digits of column 3. 1, 3. No 0. 1, 3. 4, 6, 7, 8, 9. Obviously, this can't be 8. This can't be 3. Remaining digits of column 2. 1, 3, 4, 5, 6, 7, 8, 9. Obviously, this can't be 8. No 3. And this can't be 7. So this digit can never be 7. It sees all the 7 possibilities in this cage, which must be there. So this can't be 7. Um, hmm. These can't be 1 because of 1 in the box. Okay. Um, hmm. Hmm. Uh, this is convoluted. Yeah, I don't know. I wouldn't put this as challenging. The logic is not that hard. So the logic is probably a little easier. Well, no, even then, the logic is still like yin yang shading isn't necessarily trivial. And this isn't trivial either, right? So, huh. Uh, if you have 2, you have 2, 8. Can this ever be 1? I think the answer to that is no, right? If this were 1, it can't be the 7, so it must be part of the blue. But then you have 1, 9, 8, and 2 at most, which adds up to 20. So this can't be 1. It could be 2. You could have 8 and 9 here. Hmm. Okay. Oh, you're guaranteed a 5 in this cage. So it cannot be 2, 5, 9, adding up to 21. So you're guaranteed a 5 in this cage. So it's 2 and 5. The other 2 remaining digits must add up to 21 minus 7, which is 14. So you can't have 5, 9. So this has to be a 7 here. But it could be part of the adding 7, right? It could be 7 and 7 to add up to 14. Or it could be the multiplication. We don't know. So this is 7 guaranteed, which eliminates 7 in the rest of the column, the box, and the row. So this is 6. This can't be 6. This is 7. This 6 eliminates 6 in the rest of the column. So this is 4, which eliminates 4 in the rest of the row. So this is 6, 7, 8 as a triplet, which eliminates 6, 7, 8 in the rest of the box. So this can't be 6. This is 9, which eliminates 9 here. So it's 6. This has to be a 1, 3 pair. That eliminates 1 and 3 in the rest of the column. And this can't be 1, 4, or 7. So this is 2, which eliminates 2 here. So that's 2 there. We don't know if this is green or blue. This can't be 9 anymore. This 7 eliminates 7 here, so it's a 1, 4 pair. And this can't be 1, 3, or 4. So this has to be 9 here. 4 is one of these two. This can't be 7 anymore again. This can't be 7. These can't be 9 because of 9 in the column, and this can't be 9 because of 9 in the column. Okay, it could be 7 and 7 with 5 to add up to 21. Or it cannot be 5 and 9 because the 5 is already there. So 9 can never be in this cage anymore, which means where's 9 in this box? It has to be here. So this is 9, which forces this not to be 9, so this is 9 here. And it's either 5, 6, and 8, or 5 and 7. This has to be blue either way, though. And it has to be 5, 6, and 8. Because this can't be 5, 7, 7 anymore. So this is 6 and 8. 5, 6, and 8. This forces this to be not 8. So this is blue. This is green. 6 eliminates 6 here. So this is 9 and 6. No 5 here. Where's the 5 in box 6? It has to be here. So this is 5. No 6, no 6, no 6, no 8, no 8, no 6. This becomes a 4-7 pair in box 4, which eliminates 4 and 7 in the rest of the boxes. Can't be 4 or 6. It's 3. That eliminates 3 here and 3 here. We have a 4, 6, 7, 8 quadruplet in box 7, which eliminates 4, 6, 7, 8 in the rest of the box. This can't be 4, 8. This can't be 7. It's 1 or 3 here as a pair. We have a 1, 3, 1, 3 pair in columns 3, which eliminates 1, 3 in the rest of the columns. Can't be 1 or 3. It's 4. That eliminates 4 here, 4 here. This can't be 8 because of 8 in the column. So one of these is 4. Can you ever have 4 with 3? Yes, 4, 3, 6, 7 works. Oh boy. We're guaranteed a 4 here. So 2, 8, 5, 6 adds up to 21, so that's fine. We have to figure this out then. This is the last part. Okay. It could be 1, 4, 7, 8 to add up to 20. So 1, 4, 7, 8. Or if it's 3, 3, 4, 6, 7. Oh, this can't be 6, 7. Because that would eliminate all possibilities for that cell. So it must be 1, 4, 7, 8. Again, we tried 3, 4, 6, 7. We guaranteed a 4 here because 4 can't be here, here, or here in this column. So we're guaranteed a 4 here. If we try it with 1 and 4, it's 1, 4, 7, 8. That works. If we try it with 3, it must be 3, 4, 6, 7. And the 6 would have to be here, and the 7 would have to be here. But that would eliminate all possibilities for that cell, though. So this cannot be 3. This is 1, which makes this 3. 1 eliminates 1 here, so it's 3 and 1, which eliminates 1 here, so it's 3 here and 1 here. No 1 here. We have a 3, 4 pair. Oh, sorry. We have a 4, 8 pair in row 8, which eliminates 4 and 8 in the rest of the row. And also this has to be 1, 4, 7, and 8 to add up to 20. So this is 8, which means this can't be 8. That's 7, which means this can't be 7. That's 6, which means it can't be 6 or 7. This is 8, which eliminates 8 here. So this is 4, which makes this not 4. That's 7, which makes it not 7. That's 6. 7 eliminates 7 here, so it's 4 and 7. 4 eliminates 4 here, so this is 8 and 3. 4 here eliminates 4 here, so this is 7. which means this can't be 7. No 6 here. This 7 eliminates 7 here, so this is 1, which makes this 7. 1 eliminates 1 here, so it's not 1, it's 4, which makes this 1. 4 and 7 eliminate 4 and 7 here, so it's 6. This can't be 7 or 8, so it's 4. And 4 eliminates 4 here, so that's 1 and 4. Woo! Yeah, the execution of this, yeah, I don't know. I would not put this as challenging. I would put this as hard. The logic isn't that trivial here. Like, to get the actual shadings is not that trivial. And the factorizations you have to do and the additions you have to do are are definitely harder than challenging, I feel. So I would put this as a hard puzzle, not a challenging puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.